Okay, let us discuss the problem of statistical inference. So the problem generally is a problem where you have some data, and this data takes the form of a sequence of observations, and then from this data you would like to understand what is the process that has generated this data, what is the model, okay? And by model we are going to think about probability distribution. So the question is to find out which is the distribution that has generated this data, okay? And we're going to assume that these n observations are all independent observations, so they are observations done under the same condition, which essentially means that we are going to think about this sample as a sequence of IID draws from this probability distribution. Okay, so there are three different settings that I would like to discuss. The first is hypothesis testing, and so this is the question where we ask whether Q is equal to particular distribution P1. We want to decide whether this sample comes from a distribution P1 or a distribution P2, which are given. So this is generically a decision problem. So it's a decision problem, and you may think of that in many cases this is the relevant question you want to ask. Say, for example, if you want to design an alarm system that goes on when something happens, when you detect something in your environment, then you have to decide, make a decision, given your sample, whether you are in a normal situation or whether you are in an alarm situation. And this, you can think that this is also relevant for living systems, because say for a bacterium, what can be alarming is the fact that there are antibiotics in its environment. So in this case, he has to decide to mount a particular response. So all these problems, I mean, all these problems have the flavor of hypothesis testing. So the second type of problem is parameter estimation. And this is the situation where you know that your probability distribution, you know, or you assume that your probability distribution belongs to a particular class, a family of model, which is parameterized by some parameters theta, and then you want to find out what is the particular value of theta. Okay? And the third problem that we are going to discuss is what is called model selection. And model selection has to do with a situation where you don't know whether your Q is described by one parameter model, one parametric model, or another parametric model, or so you have a different possible parametric models that can describe, that can be possible, that you consider, and you want to find out which of these models is the best one. So this means that, of course, each of these models, for each of these models you have to solve this problem. So find out what are the parameters that best describe your data, and then given this you have to solve, you have to find out which of these models best describes the data. Okay, so I will also comment on another set of topics, which is related to, say, model-free inference. And so the idea is that essentially all of these work when the number of data that you have is very large with respect to what? With the, well, very large with respect to the dimensionality of your problem. Okay, so each of these x can be a vector in a very high dimensional space. So for example, you can think each of these vectors here can be, for example, say a list of the expression of all the genes in a particular organism, and you can have many different samples of these gene expression data, for example. And well, these typically there are 20,000 genes in a particular organism, so this can be a very high dimensional system. So so what we want to do is to do high dimensional statistics. Okay, so, and of course, all this, all what I've been telling you, does not really work when the dimensionality of your data is very, very high, because you don't have enough data to estimate parameters and also to select models. So, actually, this this domain is the domain that is attracting a lot of attention, because if you think, for example, at machine learning typically operates within this domain, and where essentially, for example, if you want a machine that can classify images, so images are very high dimensional objects, and the number of images that you have may not be enough to estimate a particular model. But say so this, say for example, problems in deep neural networks or deep learning, say, fall within this class. And so I would like to give you an idea of how this new domain is related to all the rest. As we are going to see in all these three subjects here, we are going to draw on what we have learned about probability and information theory. Okay.